Hi. In this paper, we study the computational complexity of changing HTN domain models. This is a shared work by Songtuan and Pascal from the Australian National University. Well, in practice, it is often the case that a planner's behavior may be different from what a user expects. For instance, a planner may report that a planning problem is unsolvable, but the user thinks it is not. Or a planner provides a plan that is different from the one the user has in mind. In such a case, the user may wonder why this happens. That is, they are looking for the explanations to the questions like why this plan is not a solution. Well, on the other hand, if the user involved is a domain modeler, he or she may want to change the planning model so that the planner's behavior is in line with the anticipation. Therefore, the user may need modeling assistance when the model is rather complicated. For both cases, we have to solve one problem, that is deciding whether we can change the planning model so that the given plan will be a solution. We will investigate the computational complexity of this problem in HTN planning. We will also consider the given plan in different forms. For instance, it could be a partially ordered plan or a sequential one. Well, in contrast to classical planning, HTN planning has component tasks on top of actions, which are called primitive tasks. Component tasks are kept being refined until primitive ones are obtained. A set of component and primitive tasks with partial orders defined over it is called a task network. Each component task is refined into a task network by some method. Well, the most important part is the solution criteria. The standard definition is that a task network is a solution if and only if it is a refinement of a given initial task network and it has one feasible linearization in an initial state. However, these criteria introduce an ambiguous hardness source because deciding whether a task network has a feasible linearization is already NP-complete. Therefore, in order to get rid of this hardness source, we introduce another solution criteria. Instead of asking for one feasible linearization, we demand that all linearizations should be feasible, which is proved to be polynomial time decidable. Therefore, in most of the time, we will follow this solution criteria so that we can know where does hardness come from. For the purpose of changing planning models, we first define some model change operations which change the methods in a model, namely adding and deleting primitive tasks and adding and deleting ordering constraints. HPlan formulate the problem as follows. Given an HTN planning problem and a task network, we want to decide whether we can change the planning model so that the task network will be a solution. As we have said before, the problem is NP-hard anyway if we demand that a solution task network only need to have one feasible linearization. Therefore, the question of interest is whether NP-hardness holds if we demand that every linearization of a solution task network is feasible. The answer turns out to be true. For more details, please look at our paper. Well, although we did not dig deep into the proof, but we can still see that one hardness source is that we don't know which decomposition method sequence can lead to the solution task network. So to filter out this hardness source, we consider another scenario in which we are given not only a task network, but a sequence of methods which is supposed to generate the task network in question. And we still want to decide whether we can change the planning model so that the task network can be a solution, which is NP-complete as well. Lastly, we go back to the solution criteria, which requires that a solution task network only need to have one feasible linearization. We then asked a question whether we can change the planning model so that a sequence of primitive tasks is a linearization of some solution to the planning problem. Well, this one turns out to be NP-complete as well. So in conclusion, we study the complexity of changing HTN planning models with regard to user inputs in different forms. Well, the plan could be totally or partially ordered, and all tasks are NP-complete independent of what or how many changes they are allowed. Yeah, so that's the end of my talk. Thank you so much.